Let's use what we've learned to multiply 7 times 8. First we'll multiply the complements, 3 and 2. 3 times 2 equals 6. 8 minus 3 equals 5. That 5 times 10 equals 50. 50 plus the earlier 6 equals 56, the answer to 7 times 8. Instead of subtracting 3 from 8, we could have subtracted 2 from 7. It works both ways every time. Earlier we learned to add the two factors and subtract 10 to determine the distance between pairs like 6 times 8 and 4 times 2. We found that we could actually just ignore the tens digit in the sum, which is the same thing as subtracting 10. We now know that we can cross-subtract to get the same answer. To multiply 6 times 8, first multiply the complements and then add that answer to, in method 1, 10 times the ones digit in the sum of 6 and 8, and by method 2, 10 times the difference between 8 and 4, or 6 and 2. Let's look at the connection between the adding and cross-subtraction methods. If the two factors are x and y, their complements are 10 minus x and 10 minus y. Using the earlier method 1, we use x plus y minus 10, and by method 2, we use x minus 10 minus y. Both methods work because we are subtracting 10 in either case. Note that when you subtract a minus y, you end up with a plus y. Some people have wondered why you can cross-subtract either way and get the same result. For me, the easiest way to understand is to express the complements as x and y, and the factors as 10 minus x and 10 minus y. The two cross-subtractions would be 10 minus y minus x and 10 minus x minus y. You don't have to be an expert to see that these are equal. If using formulas doesn't help you, let's look at it this way. Suppose we wanted to multiply 5 times 5. We'd first multiply the complements 5 times 5. If we cross-subtracted either way, we'd get the same answer here, 0. If the second factor went up to 6, we were multiplying 5 times 6. Notice that the complements would now be 5 times 4. When you subtract 5 from 6, you get 1. But the complement of 6 went down 1 to 4. If we subtract that 4 from 5, we also get a 1. If the left-hand factor, 5, went up to 7, the cross-subtraction would now be 3. But 7's complement went down to it also, so when we subtract that complement 3 from 6, we'll also get 3. Both cross-subtractions will always be the same. A changed factor will affect one subtraction result, and the change in that factor's complement will affect the other subtraction result the same way. Suppose we wanted to use 7 times 9 as an example. In light of what we have seen, we could say the ones digit in the answers to 7 times 9 and 3 times 1 will both be the same complement to the 7 in 3 times 9 equals 27. 3 times 9 will be in row 3 and column 9. That 3 times 9 plus 7 times 9 must equal 90, or 10 times 9. And that 3 times 9 plus 3 plus 1 must equal 30, or 3 times 10. The difference between 3 times 1 and 7 times 9 will be the same as the difference between 30 and 90. I doubt if we'd really want to say all that, however. Instead, we're more likely to forget all about 3 times 9 in the rows and columns. We would likely say, subtract 3 from 9 and put a 0 after the answer, multiply 3 times 1, add the answers from step 1 and 2, and that's all. You have your answer to 7 times 9. 7 times 9 equals 60 plus 3. Now let's go way back to where we began in part 1 of this series. That's where we first saw that you could multiply two factors and then multiply those factors' complements and end up with the same ones digit in the answer each time. It's fun to note that you can actually determine the distance between 9 and 49 by counting the hops or jumps between the two columns. Between 3 and 7 there are 4, and the difference between 49 and 9 is 40. Based on what we've been studying, you and I both know that what's happening here is we're subtracting a row from a column to find the distance between the two numbers and then multiplying that by 10. Isn't it nice to be able to understand and know why tricks like this work? Almost every child learns this trick for multiplying in the nines. If you want to multiply 9 times 3, as you see in this example, you bend the third finger down, you look at the two fingers to the left of the bent one and say 20, and look at the 7 figures on the right of the bent one and say 7. The answer to 3 times 9 being 27. Let's look at this trick in light of what we've been studying. We want to multiply 3 times 9. The complements are 7 and 1. We're looking at 10 fingers. If we set off 3 of them by bending the third finger down, the remaining number of fingers out of the 10 is automatically going to be 3's complement, 7. Multiplying that 7 times 9's complement, which is 1, will tell us that the product of the complements is going to be 7. 9's complement being 1, if we subtract it from the 3 in 3 times 9, our answer is 2, which tells us that we have to add 20 to the 7 that we got earlier to give us our answer 27. Here's a sneak preview at what I consider the best of all finger tricks. We're going to be exploring it in part 5 of this series. Take a look here, and I think you'll want to continue.